he's going to take that 42 plus 24, and he's going to take that and convert it into something else. He's going to make it look differently. He's going to write it differently. Ultimately, he's going to write it so that it looks like this. 6 times 7 plus, what is it? 3. Nope, 7 plus 4, I'm sorry. Somebody tell me, what is 42 plus 24? 66. What is 7 plus 4? 11. We have to follow our order of operations, right? We got to do stuff inside the parentheses. So 7 plus 4 is 11. And then this right next to the parentheses means multiplication. So what is 6 times 11? 66. Okay. This is using the distributive property. Okay. What is 6 times 7? 42. What is 6 times 4? Equals 66. That is our goal. We're going to get there, but there's a few steps in order to get there. You can't just pick any random numbers. Okay? This is called factoring. So let's listen to it.
2 plus 24, and see if we can write it in a different way as a product. And this is done by what's called factoring. And the way that we think about factoring is actually using the famous distributive laws. So the first thing I want to do is I want to look for a common factor. In fact, I want to find the greatest common factor. That's the largest number that is a factor of both of these numbers. And then in some sense, I'm going to kind of pull it out using the distributive laws. So check it out. To find the greatest common factor, which a lot of times is abbreviated GCF for greatest common factor, what we do is just factor each of the numbers into the smallest possible components. So we take 42 and we factor it. Notice it's 2 times 3 times 7. And then we take 24 and we factor it. Turns out 2 times 2 times 2 times 3. And you can check this for yourself, by the way. What's 2 times 3? That's 12. And if you multiply, 2 times 3 is 6. Now, why would you let me say 12? 2 times 3 is 6, but times 2 is 12, and times another 2 is 24. You can see, you get the product of these, you get 24.
So all he's done so far is he's done the factor trees like we did for today. He did this factor tree, and he did 42, and he did 6 times 7, and then 2 and 3, and then for 24, 6 and 4, 2 and 3, 2 and 2. So he came up with all of these numbers. For 42, he came up with 2, 3, 7. For 24, he came up with 2, 3, and then 2, 2. Remember, I kept these columns separate, right? Our greatest common factor, these together, is 2 times 3, so our greatest common factor is 6. That's our first step in factoring. We need to find the greatest common factor. So that's what he has done here. Okay?
Now, the greatest common factor will be the product of the factors that both of these share in common. That's why it's called a common factor. So, for example, notice they both share a common factor of 2. So I'll write that down right here. Okay, so I've taken care of that 2. And notice that these have other 2's, but there's no more 2's in 42, so I'm done with that. But they both share the factor of 3, so I can write that down. So multiplied by 3. So I got rid of that common 3. And now notice all the other factors they do not have in common. So these are actually not common factors. So the greatest common factor will be the product of 2 times 3, which is 6. So 6 is the greatest common factor. Okay, great. So now what I have to do is I can now write this in sympathy with this common factor, this greatest common factor of 6. And when I do that, what do I see? So I can write the 42 as, well, we see 6 multiplied by, well, that's 7, because we already have that 6 right there. So notice 6 times 7 is 42, and that's all that we said before. And now plus the 24, I'm not going to write as 2 times 2 times 2 times 3. I'm now going to write it as 6 multiplied by the factors left over, which in this case is 2 times 2 or 4. Now you're saying, gee, why would we write it this way?
Okay. So what he has done now is he's taken the 6 part out of this, the greatest common factor of 6. So we have 6 times, what times 6 is 42? 7. Plus 6, which is that. What times 6 is 24? 4. Now notice, this is the kind of the neat part of this, is you already knew 6 times 7 is 42 and 6 times 4 is 24. We did our factor tree and we made our little chart and we used this 2 and we used this 3, right? Do you see how that works? Now, the last step in factoring is using the distributive property. And I'm going to confuse you a little bit. Because we have these in this form. Remember, we have variables, and variables are letters. We use letters to represent numbers. Numbers can change, letters can't. So these letters represent different numbers. I'm going to have the letters A times B plus A times C. In this situation, A represents the number 6. What does B represent? 7. And what does C represent? 4. If we had a completely different setup here, let's say we had 7 times 3 plus 7 times 6, what would A represent? What number would A represent in this situation? 7. What number would B represent in this situation? 3. And what letter would C represent? 6. Okay. So when expressed or shown algebraically, factoring looks like this: A plus B, or A times B plus A times C equals, I got to write it shorter, A times B plus A times C equals this: A, and then parentheses, B plus C. So what I'm going to do is I'm going to rewrite this thing right here. I'm going to rewrite this in this form. So I'm going to take this 6 and I'm going to put 6 times, what is B? 7 plus, what is C? 4. And that's how I rewrote it. Does this still equal 66? 6 times 7 is 42, plus 6 times 4 is 24, which equals 66. Or we can use the order of operations. 7 plus 4 is 11, times 6 is 66. So do you see how that was all written that way? And how we get from A times B plus A times C equals A, and then parentheses B plus C. Yes?
Whenever you do that 6 times 7 and you put the letters below it, are they usually like the answers? Is it usually the answers and numbers that you're multiplying and adding?
I'm not understanding your question particularly.
Because like 6 equals 8.
Yes? In this situation.
And then A, or yeah, A times B plus C, and A equals 6, and then B is up there, so that would all B equals 7, and C equals 4. So that would all be the same.
Every time you set it up this way, yeah, those will all transfer over to those letters. Okay? Okay, the first problem on your worksheet says 18 plus 20. So we have this problem, 18 plus 20, and the directions say what? Factor the sum in terms of the product of the greatest common factor and a sum. So basically what we're trying to do is we are going to convert this to this form. Step number one, we need to find the greatest common factor. That's step number one. So in order to find the greatest common factor of 18 and 20, we need to use factor trees. 18 is going to be what? 6 and 3 and 2 and 3. And 20 is going to be 10 and 2 and 5 and 2. So we can make our little chart. We can make our little chart. We have 18 and we have 20. And for 18, it's 2, 3, 3. And for 20, it's 2 and 2 and 5. So our greatest common factor for this problem is what? 2. That's our greatest common factor. So what we need to do then is our original problem, 18 plus 20, is we need to get the 2 out of there. So we have our problem 18 plus 20, and I'm showing a lot more work than you have to show on your sheet, but I'm trying to demonstrate what we have to do. So now our problem is going to be this. We want to get it in that A, we want to get it in this form. We want to get it in this A times B plus A times C form. We want to get it to that form. So we have this times this plus this times this. First of all, our A is what? What did we decide A was? 2. So 2 goes here, 2 goes there. What times 2 is 18? 9. What times 2 is 20? 10. So now we have it in this AB plus AC form, that AB plus AC equals A times parentheses B plus C. So the ultimate form that we want to get is this. This is our answer right here. We want to get it to that. So in that situation, we're going to have this times parentheses plus this. What goes in this spot? What is A? A is 2. What is B? 9. And what is C? 10. There's our answer. We're done. Our answer is 2 times 9 plus 10. Okay? Yes? No, this is it. This is your answer. This is what you need to write on your line on the worksheet. Once you're done, once you've done that, you're done. That's it. We want to take the problem, the original problem, 18 plus 20, this problem right here, and the question asks us to rewrite it in the form of a greatest common factor times the sum. And that's what we have. We have a greatest common factor right here times a sum, 9 plus 10. Yes? Now, what do you mean what letter? You're looking at your thing and seeing like number 7 says 10y?
No, like, on the question, like, 2 equals A, doesn't matter what kind of letters you have?
No, I want you to use A, B, A, C.
Oh,
Do not change the letters. No, I want you to use, that's the form. Yes.
okay, so is it always that same exact form?
You could, yep. I want you to always get it, try to get it to this form.
So it's always,
A times B plus A times C. I want you to get it to there, and then from there, you can get it to A times parentheses B plus C.
oh, this is easy.
Yes. Now, we'll get into that kind of problem tomorrow. For your homework, the only things I want you to do, I want you to do 1 through 6, and I want you to do 13 and 14. So your homework is number on that worksheet is 1 through 6, and then 13 to 14. That is your homework assignment. Now, let's do number 2 together as well. Number 2 says, what's the problem? 35 plus 15. 35 plus 15. Now, with 35 plus 15, you guys can do all the work and you can figure out what the greatest common factor is. Do you know what it is? Do you happen to know what it is off the top of your head? It is 5. The greatest common factor is 5. So in order to get it in this form, A times B plus A times C is A is 5 times what is 35? 7 plus 5 times what? Lacey. 5 times what is 15? 3. From there, we need to get it in this form. A times B plus C, which is, Lacey, can you help me out? What is A? A is 5. What is B? 7 plus what is C? 3. There's our answer. You know what? If you can show that much work, that's all you need to do. I'm okay with that. Once you're not being asked to solve. If you want to check your work, that's fine. What is 35 plus 15? 50. Okay, that's right. That's a good way to check it. You know that that's 50, okay? What then? I'd follow the order of operations. What's 7 plus 3? 10. So if that's 10, what's 10 times 5? 50. If those two numbers match, you know that you're right. Okay? Is everybody okay with all of this? All right. If you have other questions, please refer back to these, or if we're still in school, come talk